Look. Okay, tonight's homework is on page 45. It's a multiples of 10. All right, so 10, 20, 30, 40, 50, like that, okay? Let's take a look at some sample questions like that. Okay, so let's start. Take a look at number 15. Okay? So we're on page 45, number 15. Just reviewing how to do word problems. All right, so in a word problem, you basically have to come up with an equation yourself, translate the words into an equation, and then solve the equation. But we know how to solve equations because we did that last time. Oh, we're so good. All right, here's number 15 on page 45. Is everyone on page 45? All right, what are we talking about? The perimeter, right. Okay, the perimeter of a rectangle is 60 feet. Find its length and its width if the length is 8 feet longer than the width. All right, so the first thing you got to do is figure out what you're missing. What information you're going to calculate? The length and the width. Okay. But it says that the length is 8 feet longer than the width. So everything is based on x is who? X stands for what? The width? Okay. Now, so this is the first thing you do. First thing you do is define your variables. Now, since you have a figure, a rectangle here, I might as well just define my variables by drawing a little graph or a little diagram, okay? So if the length is 8 feet longer than the width, let's say x is the width and the length? X plus 8. Now they want you to solve for x basically so that you get x and x plus 8. But the only other information we have is that the perimeter is 60 feet. So how do you write an equation that involves these variables or this variable and the perimeter of the shape? And Zach, go ahead. All right, so 2x, we got two widths, plus 2 times x plus 8, the whole thing, 2 lengths, equals, what did you say it? 60, there, that's it, done. All right, so geometry questions like this very often have to do with perimeter or area. Area would be different. How would you get the area of a rectangle? Length times width, so x times x plus 8 would be 60 in that case, okay. All right, so first step, define your variables either with some kind of a diagram or a let statement. Have you used let statements before? Well, we will, so hang on. Let x equal the width, right, that kind of thing. And then use those variables to translate the words into an equation. So let's solve the equation. That's the third step. What would you do first to solve this equation? Distribute, okay, so 2x plus what? 2x plus 16 is 60. Okay, good. Now what would you do? So you get 4x when you combine like terms, right? And what would you suggest to do next? Subtract the 16, so 4x equals? Something? No. 44, which is convenient because x is clearly 11. Okay, so now what did we do? First step, define your variables. Second step, use them to rewrite the word problem as an equation. Third step, solve that equation. Fourth step, restate the answer. X is 11 mongoose, right? X is 11 miles, parsecs, inches, seconds, cows, moons, chickens. What is it? Feet. Say so. Okay. So the width is 11 feet, and the length would then be 19 feet. All right, so there's the steps. Define your variables, the x and the x plus 8. Write the equation, solve the equation, restate the answer in the context of the problem, usually meaning if there's units in the question, there's units in the answer, right? Now, does this work? Can you check it?
Yeah, check it.
How are you going to check it? Add them all up, right. So what's 11 plus 11? What's 19 plus 19? 38. What's 22 plus 38? 60. Check. Good. There you go. All right. Is this terrible? No, it's not. All right, let's try another one like that. Remember, you have 10, 20, 30, 40. All right, how about 18? Jumping around a little bit. 18 says, I'm jumping around, hang on. Let's see. We're going to do something like 19. I don't know if it's 19, but we'll get there. All right, so 18 says, going into the final exam, which will count as 2/3 of the final average, Mike has test scores of 86, 80, 84, and 90. What score does Mike need on the final in order to get a B, which is an 80? And also, you could ask the same question, how to get an A, which is a 90, okay? So, how would you do this? Average stuff, right? Okay, but it's a special kind of average. It's a weighted average. One of these grades counts more than the rest. The final counts 2/3, or 67% roughly, right? So who's X? What's the variable here? What are we calculating? The grade on the final, right? Now this isn't the geometry, so I'm not going to draw a diagram. I'm just going to say let X equal the final exam grade. Final exam grade. And that's what we got to figure out. And that's it. That's all we got to figure out. All right, now can you write an equation that says the average of this final and all those grades, what are they now? Let's see, 86 and 80 and 84 and 90. Is there a way to figure out, to make this average out to an 80 if your final is an X? If your final is X? All right, well, how do you average stuff usually? Add them up and divide by how many? How many have we got? 5. So you're going to add up and divide by 5? No. Are you going to just add up and divide by 5? No, why not? Because this counts more than the other tests. This counts 2/3 of the whole grade. This is, if we divide by 5, then each one of these counts as 1/5 of the grade. I want this to count 2/3. How do I make this a weighted average? No. I need this to count 2/3. I need this to count 1/3 for the average to be an 80. Well, all right, how about this? If I have 4 grades, and that's supposed to be 1/3 of the grade, and all the grades weighted equally, how many tests would that be? If 1/3 of your grade is 4 tests, I need 12 tests, right? So I have 4 here, I need how many more? 8 out of 12. There you go. That's what they want.
Oh my God.
That's what they want. Okay. Since they want this last grade to count 2/3, and all of these 4 grades together to make only 1/3, if 4 grades is 1/3, 12 grades is the whole thing, 3/3. Right? If 4 grades is 1/3, well, I'm not going to write it that way. If 4 grades makes 1/3 of the grade, then you need 12 grades, don't you, to make 3/3. So I'm missing the equivalent of 8 grades out of 12. Isn't 8/12 2/3? So it makes it worth 2/3. Okay? So solve this equation. There you go. So we defined the variable. We used it. We used it to rewrite the word problem as an equation. Now we've got to solve that equation. And so how are we going to do that? What would you do first to solve this equation for x? Any ideas? Combine like terms? Combine all these constants? Yes? Okay, sure. And I'm sure this is not that tough to do by hand, but just for fun, let's bring out Ziggy. Okay, so here's Ziggy. Now, did we explain this thing about the name? The name of this thing is Ziggy? I've been teaching this stuff since before the TI-81. And then we used the 81, then we used the 82, then we used the 83, then we used the 84, then we used the 85. I got sick of using all these numbers, so I gave them names, nicknames. All right? So all my calculators that I've ever used have a nickname, and they all come from sci-fi shows because I'm into sci-fi. Okay? So this one, since it's a TI-83, I figured it rhymes with Ziggy. Right? So I called it Ziggy. But Ziggy comes from a show called Quantum Leap that nobody knows anymore. Do you know it? Have you seen it? With Scott Bakula? Yeah? No? It's a scientist who was trying to come up with a time machine or something, went kaflooey, and somehow his, I don't know what, they never really figured it out, his soul or something, jumps from person to person all throughout history, like famous points in history. And it turns into a sci-fi show, history show, you know, and there was a pilot, there was a movie pilot. And so anyway, it was a fun show. And the computer that was used to control the jumps was called Ziggy, and it was a little computer that looked like a calculator. Quantum Leap. quantum loop. Okay? All right, anyway, so that's Ziggy. I also use the TI-89 a lot. I call that HAL, because the TI-89 is evil. You think it's very powerful. It gives you really weird results if you don't know what you're doing. So the TI-89 is not a good calculator to use unless you know what you're doing. So I call it, that's the other calculator that pops up sometimes, okay? I have to use that in Calc BC, in 5H BC. I call it HAL because that's named after an evil computer that like killed everybody in the movie. You know this movie? HAL was a computer. It took over a spaceship. It killed basically everybody on the ship, except for Dave.
Star Wars.
Not Star Wars, way before Star Wars. No, way before iRobot. But the producer, or the director was Stanley Kubrick. The story was based on a novel by Arthur C. Clarke.
War of the Worlds.
No, a little bit after War of the Worlds.
2012.
No idea, huh? 2001, A Space Odyssey. Look it up, it's a great movie. All right, anyhow, we digress. So let's use the calculator. Let's add this stuff up, huh? 86 plus 80 plus 84 plus 90. Not that you couldn't add those in your head, I suppose. Is 340. So let's go over here and write that down. 340 plus 8x over 12 is 80. Okay. So now what do you want to do to get x alone? Question? Was there a question? No? What would you do next to get x alone? I got to get rid of the 12, I got to get rid of the 8, I got to get rid of the 340. Divide 340 by 12? That may be messy. I don't think I want to do that. Huh? Multiply by 12. Get rid of it. It's dividing. How do you get rid of it? You multiply. All right, so 340 plus 8x equals 80 times 12. Now, you could do that on the calculator, but do you really have to? What's 8 times 12? Do you know your 12 times tables? Come on. 96. But it's 80 times 12, so 960. 10 times bigger. All right, now what? Yes, and then times 10. Subtract the 340. How much do you get when you subtract 340 from 960? You get 620. Good, okay. And then we want to divide that by 8. So 620 divided by 8. Well, that doesn't go nice and even, does it? Because if you divide by 2, it's 310 divided by 4. And you divide that by 2, it's 155 divided by 2. And 155 is not even. What do you get?
155.
Yeah, but
77.5.
yeah, but this represents 77.5. Good, that's exactly right. Okay. But now wait, now we have to interpret that answer because that really doesn't make sense. I want that to be my final exam grade. When was the last time you got a grade on a test that says 77.5? Or is anything 0.5? That's weird, right? So usually the teacher sets up the exam so the grades come out exactly 77 or 78, or maybe they round up, right? Now, do you round up or do you round down or truncate? Why? Yeah. Well, remember, 77.5 will give you, if you put 77.5 in here, that'll give you exactly 80. So 77 isn't enough if you want an 80. So 78, I guess. So I'm going to say it's the x is 77.5, but I'm going to make a little note here. At least, I need at least a 78 though, because nobody's going to award you a grade of 77.5. That's just weird. Okay? Okay, so that, that at least, doesn't that hint at inequalities? I probably could have made this a greater than or equal to problem. And then the answer would have been greater than or equal to 77.5. That would make sense. So I could have solved this as an inequality instead of an equality, instead of an equation. Either way. All right, so any problems with defining the variable, rewriting the word problem as an equation, solving the equation, and restating the answer? Now, you probably want to check your work though. How are you going to check your work?
Plug it back in.
You can plug it back in and see if it works in the equation. But what if you didn't write the right equation? Remember, they didn't give you the equation, right?
Well, so then you just add the x.
Actually do it, but that's what the equation says. Okay.
Just add all the numbers
Okay, you can do that. That's an option. Actually average out all 12 numbers. Right, yeah, sure. Another option, though, that's good, that's fine. But another option is there another way to solve this? If there's another way to solve it and you get the same answer, that's a check. Here's another way to solve it. Remember that these four numbers added up to 340? So what if I asked you, instead of all of this, what if I asked you, what's this average before the final? How do you get the average of four numbers? Just that. Add them up and divide by 4. Okay. Oh, is that what you were saying? Okay. I misunderstood you. All right, so what's 340 divided by 4? Well, divided by 2, and you get 170. Divided by 2 again, and you get 85. Now look at this. If I want 85 to be 1/3 of the grade, and I want the final exam, X, to be 2/3 of the grade, what does the equation look like now? It's a little different.
Plus X.
Plus, not X. I want this to count twice, I want this to count once.
2.
So 2X divided by 3, because now it's 3 grades, is still 80. Here's a whole other way of doing the same problem. And let's see if we get the same answer. That's a check. Okay, just for fun, you could have set this up, just see if that's what you were thinking. All right, so this counts once, this counts twice. That's called a weighted average, where one grade counts more than another, or one number counts more than the other in the average. Okay, how do you solve this equation for X? All right, so 85 plus 2X equals how much? 240, good. Now what? All right, so 2X equals how much? Subtract 85 from 240 and you get 155. And then what do you do to get rid of the 2? And didn't we have 155 divided by 2 the last time? Which is, in fact, 77.5. But look, we actually even had that exact number. All right, so the same result, right? So we did the question 2 different ways. We've got the same result, so that's a check. That's a good check. Right? More than one way to skin a cat, right? Okay. Never heard that phrase? More than one way to skin a cat? I'm sorry, I'm a dog lover, so if I see a cat, he's in trouble. Huh? We digress. Didn't mean to talk about my personal life, sorry. All right. All right. Someone said let's do something like 19. I'm doing something similar. Let's do 23.
Let's do number 10 and 20.
That's homework. I can't do that. It's illegal. It's throw me in jail. Sorry. No, because that's your assignment. Tonight. I don't want to gyp you of your experience in doing your homework. Yeah? You never got the original assignment sheet? Really? Here, how did you take that one? I'll get another one. Alrighty. So, 23. Take a look at 23. It says, Betsy, a recent retiree, requires $6,000 per year in extra income. I guess her retirement isn't good enough. She needs $6,000 more a year to cover her expenses. Fine. She happens to have $50,000 lying around to invest. Okay. And she can invest in B-rated bonds that gives 15% interest a year, or a certificate of deposit that gives you 7% of interest a year. How much money should be invested in each of those to get the extra $6,000? All right. Well, are you going to draw a diagram or are you going to write a let statement? It's not geometry, so there's no picture to draw.
Let.
So let. Now, it doesn't have the X all the time. You want to call it something else?
Q.
Let Q for quantity of money? Fine. You want to use X? Go for it. E, that might get a little confusing. I'll use Q. All right, Q is an amount of money. Now, you have to decide. Think what's going on. You're putting an amount of money in a B-rated bond and another amount of money in a CD, and you have $50,000 to play with. So what do you want Q to represent? It's up to you. Let Q equal what?
6,000.
No, I don't know how much it is yet. In which one? In which investment? There's 2 investments.
15%.
The 15% one? Okay, how about I say the dollars invested in B-rated bonds, right? That's the 15% one?
What is a B-rated bond?
A B-rated bond is one that's, It gives you high interest, but it's iffy. Yeah, you could lose your money. So you might put some money in there because you can get a lot of interest back, but one, you're not guaranteed the interest, and two, you're not even guaranteed getting your money back. Your principal, that's bad. But it's a good risk if they give you a lot of interest. You know, so this is 15%, that's unusual. All right? All right, so now here's the key. What are you going to call the amount invested in the CDs? Yeah, you could call it something else like X, Y, Z, whatever. But the idea is to use as few variables as possible. Is there some way to write it also in terms of Q? Because you know how to... No, it's still Q. You know how... This is the idea. The problem is that right now, we've been talking about how to solve equations with one variable. One equation, one variable. So if I can stick to one variable, that would be good. Q plus? No. I don't want two variables if I can avoid it. I'm telling you, you can avoid it.
One.
Q. I already got Q. Can you use Q, the amount of money invested in B-rated bonds, to describe how much you're putting in the CDs? It has to do with Q. And it has to do with the amount of money you have already. No, that's the amount of money you want to get. 50,000. 50,000 minus Q, sure. You used Q up from the 50,000. And so how much is left to invest in the CDs? 50,000 minus Q. So that's it. All right, so let's write that down. $50,000 minus Q. Okay? So that's our aim, is to fill in these question marks, basically. Okay? Now what's the equation? Now how do you get interest, like simple interest at the end of the year? How does that work? If you have 15% interest rate, how do you know how much money you get at the end of the year? Any idea? If say I have make it easy, $100 in the bank, and I leave it there for a year at 15% simple interest, how much interest do I get? What does 15% mean? For 0.15. But 15% actually means for every $100 you put in, you're going to get 15 back. Because 15% of 100, or 0.15 times 100 is $15, right? Or, think of it this way. Interest equals rate, interest rate times time. All right? Interest rate times time. The interest rate 15% times the time, wait. I said that wrong, I'm sorry. I said that wrong, whoops. It's the principal times the rate times the time. I went crazy. It's how much money you have times the interest rate as a decimal times how many years. You ever heard of PERT? PRT? Interest problems? Never heard of that?
Yeah, last year.
Probably. So like $100 times 0.15 times 1 year would be $15, right? All right. Now in this case we're only dealing with 1 year, so let t equal 1. That's all I'm dealing with. T is 1 in this problem. 1 year. So I need the principal, the amount of money, times the rate. Okay. So this is the principal, the amount of money I'm investing.
So Q is the principal?
Q is how much I'm investing. In the B-rated bonds. So what percent interest rate do you get from that? So 0.15 times it. P times R, principal times rate. Times years, but it's only 1 year. Mm-hmm. Plus what? That's how much money you're going to get from this. How much money are you going to get from this? No, I don't know about 6,000 yet. 7%. So what's 7%? 0.07 times how much money? 50,000 minus Q, right. Equals how much money does she want at the end of the year extra? $6,000 in interest. There you go. That's the equation you have to solve. I is PERT, PRT. Interest is principal, the amount of money you got in there, times rate, the percent as a decimal, times time, the number of years. But since the number of years here in this question is 1, I'm not worrying about it.
What is P?
Principal, how much money? So money times rate times 1. Money times rate times 1. Because 1 year. Okay, equals how much interest I want. Okay, so how do you solve this equation? You can distribute. You know what? At this point, I think people get a little crazy with decimal numbers. If you're comfortable with decimals, fine. Distribute and go ahead. But is there a way to get rid of these decimals? Think of it. Isn't this 15 over 100? Isn't that what the decimal means? Isn't this 7 over 100? The 100's dividing. So how do you get rid of the 100? The 100, this is 15 hundredths, right? Multiply everywhere by 100, it makes it easier, okay? So I'm multiplying this by 100. Now you get 15Q plus 7 times 50,000 minus Q equals, what's 100 times 6,000? Well, it's 6,000 and throw on 2 more zeros, because 100 has 2 zeros in it. That's how you multiply by a power of 10, which in other words is 600,000. All right, so solve. What are you going to do next to get Q? Distribute the 7, right? All right, so 15Q plus what? 7 times 50,000? Not 35,000. 350,000, right? I mean, think about it. 7 times 50,000 is going to be 35,000. That's smaller, what? Minus 7Q equals... I did. We said 350,000, didn't we? Whoops. You're right. Good call. I said 350,000 and I didn't write it. Okay. Equals to 600,000. All right. What are you going to do next? Combine the Q's. So 15Q minus 7Q is 8Q's. Okay, fine. Plus 350,000 is equal to 600,000. All right. Now what? I keep on doing that. Subtract who from what? 350,000 from 600,000 leaves 8Q equal to what? 250, right? Okay. And then you got to divide by 8. All right, let's be lazy. All right, Ziggy. 250,000 divided by 8 is 31,250 bucks. So Q is 31,050. 31,250. Okay? So that's our solution for Q, but are you done? No. Remember what we did? You define your variables, you rewrite the word problem as an equation using the variables, you solve for that equation for the variable, and then restate the answer. Well, this is what? 31,250 watts. Dollars. Don't forget units. If there are units in the question, there's units in the answer. But what about this? Subtract the 31,250 from 50,000. Oh, okay. Let's be lazy. 50,000 minus 31,250. Why is this sticky? Is 18,750 bucks. 18,750 bucks. Ta-da! Okay? Now, what? Question? Do you have a question? No? Anyone else? Raise your hand if you've got a question so I can see you. All right, let's check this. How would you check this? How do you know if she's actually getting the 6,000 bucks? Right, fill it in. In other words, take 15% of that and 7% of that and see if you get 6,000 bucks. Okay. So, what's 15%? That's 50% as a decimal, right? Of means multiply. Of Q, which was 31,250. So the B-rated bond gives her that much money. Wait. What about the 7%? Well, we're going to add them up, right? Then we say we add them up. So 0.07 times the other amount. What was the other amount? 18,750. Is $1,312.50. Well, does that add up to 6,000? Let's see. Let's take $4,687.50 plus $1,312.50. Is it in fact 6,000 bucks? Check. There's your check. Done. Okay? All right, at this point I'm going to save my work because it takes a while to save. So hang on for 1 second. All right? All right, let's go to here.
8,000 times
Okay.
0.15.